Hello. In this example, we will decide whether each relation defines a function and give the domain and range. I'm going to start out with the functions. A is y equals 2x minus 5. Because it's an equation, that means it might be a function. And because the exponent is to the first power, which is an odd power for the y variable, that means that A is a function. So yes, it is. B, y equals x squared plus 3. Again, it's an equation, which means it might be a function. And again, it's y to the first power, which means that it's an odd exponent for the y variable. Therefore, again, yes, this is a function. C is actually something I haven't talked about yet. It's an equation, so it might be a function, but it's x equals the absolute value of y. Let's just think about this. If it's the absolute value of x, it's going to look something like that. It's a V shape. Sorry, that's the y equals absolute value of x. If it's x equals absolute value of y, what happens is that gets flipped on its side. And as you can see by the vertical line test, that's not a function. So x equals absolute value of y is not a function. D, y is greater than or equal to negative x, because it's an inequality that guarantees that no, it is not a function. E, y equals 3 divided by x plus 2. Again, it's an equation, which means it might be a function, and it's again y to the first power, which means that it is a function. Therefore, yes. Now for the domain and range. For A, it's a polynomial equation, which means it's a polynomial function. Therefore, the domain is all real numbers. Really, all I'm worried about here is the domain. But I'll go ahead and tell you that because it's a linear function and it's actually a function, that means that the range is going to be negative infinity to infinity. B, y equals x squared plus 3. Again, it's a polynomial function, which means that its domain, there's nothing that x cannot be. Therefore, it's all real numbers, negative infinity to infinity. And I'll talk about y in the next section, but this is the parabola. If I was to graph it, it's a parabola moved up 3 units and it's opening upwards. Therefore, the range is going to be starting at 3 and going up to infinity. C, the domain are the x values, but if you look at the graph here that I showed you, the domain is going to be just 0 to infinity. The range, if you can see it from the graph, will be negative infinity to infinity. Let's look at D. This, if you look at it, just consider it kind of an equation real quick. So y is greater than or equal to negative x. Just think of y equals negative x. That would be a polynomial equation, which would mean that your domain would be negative infinity to infinity. And because it's part of that for the equality, that means it's going to be part of that for the inequality as well. So the range, if we look at this again, it's again a polynomial and it's linear. So the range is going to be negative infinity to infinity. E. E is one of those where you're going to have to limit your domain. It's kind of like C, but not really. Remember, there were 2 things that I said limit the domain. The first one were even radicals. And the second one was the rational function. And if you look at this, this is the rational function. Therefore, your denominator, x plus 2, can never equal 0. Because you can never divide by 0. Therefore, if you solve for x, that means that x is not equal to negative 2. And again, if you graph it, here's what it's going to look like. If you put the negative 2 there, You can use anything to the left of -2, but you can't use that -2. And again, you can use anything moving to the right of -2, but you again can't use the -2. That's why I used parentheses for both of those. Therefore, if I was to put this in interval notation, it would be -infinity to -2 union -2 to infinity. And again, the range, I'm not going to talk about why. It's -infinity to 0 union 0 to infinity. We'll talk more about why the range is -infinity to 0 union 0 to infinity in the next chapter. It'll be section 3.5.